I don't know if I've met all of you, but my name's Andre, and I'm going to share something with you today that can help students visualize what's going on with the Riemann sums. So there's some kind of questions here in the text fields. So how do we find the area of this weird shape? Do we have any readily available formulae? So the weird shape is down here in this folder. You can change it to sort of whatever you like, and the thing is not going to break. So you can choose whatever function you like. I like this little Nike swoosh. You can toggle this area on and off. Feel free to look into the folders to see what's in there. But yeah, so we're talking with the students about how this is the actual area. How can we approximate the area? Let's say I'm really good at finding the area of a rectangle, which is length times width, right? Really wanting to emphasize length times width, or maybe width times height, so that they can make sense, right, of the, at very least, the integrand and that differential. So we have here, if you turn these on, we've got some rectangles. Question here, how many rectangles are we going to need to get the best estimate? The number of rectangles n is the total change in x as x changes from a to b, right, b minus a, divided by the width of each rectangle, which in this file we're going to call x step. So this is the number of rectangles. We've got 4. And I chose to just have this be a fixed value and only allow us to toggle x step. But feel free to mess with it and make it your own. You can do whatever you like. So I think, before adjusting that value, we can talk about this table. And it says, what quantities do the columns in this table represent? So this is my, x value at the left. And then here we've got the height of the corresponding rectangle. So then here we've got, width times height. So every entry in this column is a little bit of area that's been accumulated, right? So this is like the area of this bit. This is the area of that bit, right? Little bits of area. We can think of these as just little changes in area, dA or whatever you want to call them. So then, since the number of rectangles we can fit, n, depends on the width of the rectangle, this thing I'm calling x step. Decreasing this width also increases the number of rectangles. So we decrease the width and we increase the number of rectangles. Very cool. We can remind them, the area that those rectangles comprise is still going to be different to the actual area. And down here we have these 3 numbers. We have E, A, and D. E is the estimate, right? This is essentially our Riemann sum, just with some different notation. A is the actual area. D is the difference. If you go down here into parameters, you can change A and B, your starting and ending x value. And big N here is just a list of numbers from 1 to n minus 1. You can play with that too. Anyway, so here we have our estimate, which is found by just taking, the width times the height of each of these rectangles, adding them all up. And what's pretty cool is that even when the step is huge, right, like you can show the students the difference here in area is 0.26. And we can interpret the meaning of that negative, right? Like, so this is an underestimate. Hold on. Final minus initial. Yeah, brain fart there. Yeah, so we've got a little underestimate. But what's wonderful is that very quickly, we can see that this guy's going down. And once we get really, really, really tiny, this guy's getting really, really, really tiny. It's pretty beautiful to visualize here at like 0.01. Like the computer, or maybe my human eye can't really tell the difference, even though the computer is able to discern some difference. But beautifully. Of course, you can zoom in and see actually, yeah, we do have some differences here. We're this is all of these little bits of difference are accumulating, are adding up together to create this big, well, not big, but consequence difference here. Um, but yeah, so this is a tool for you all to play with and use it to support discussions with your students. And I hope you enjoy. Give me some feedback, please.